Oumuamua, the first visitor to our solar system of many, preparing for future visitors. For centuries, the scientific community has been fascinated by the possibility of objects from beyond our solar system drifting into our cosmic neighborhood. But nothing could have prepared us for the arrival of a mysterious cosmic vagabond in 2017. Since the discovery of Oumuamua by a Hawaiian telescope, scientists have been working around the clock to unravel the mystery of this cosmic intruder, and a lot has been revealed. The biggest questions remain. What exactly is Oumuamua? Is it an asteroid or comet, a remnant of a dead planet, or something even more intriguing, a relic of an advanced alien civilization? The possibilities are endless, and the implications are profound. Join us on this captivating journey about the mystery surrounding this interstellar object, what we have currently unraveled, and its possible connection with aliens. The thrill of scientific discovery is similar to an unforgettable journey that never fails to leave us awestruck and yields an outcome that continually pushes the boundaries of our imagination. Such was the case of this groundbreaking discovery. On October 19, 2017, the University of Hawaii's Pan-STARRS-1 telescope was scanning the space surrounding our planet, a task made possible by NASA's Near-Earth Object Observations funding. This telescope had a reputation for identifying and tracking asteroids and comets that approached the Earth. On that particular date, the Pan-STARRS observers detected a new object about 33 million kilometers away, which they labeled 1I 2017 U1. What caught their attention was the object's extraordinary speed, clocking in at over 314,000 kilometers per hour, more than 4 times the average speed of objects originating within our solar system. Initially, the question was whether this object was a comet or an asteroid. It didn't display any signs of cometary activity, such as a tail of gas and dust, leading the observers to assume it was an asteroid. However, it was slightly accelerating, a characteristic more commonly associated with comets. The nature of the object would remain a topic of debate for years to come. What was clear to the observers in Hawaii was that they had discovered an interstellar object, ISO, an object that originated from another star system and had entered our solar system. This was a groundbreaking find, as NASA confirmed that 1I 2017 U1 was the first object from another star system to visit our solar system. It's worth noting that astronomers estimate that ISOs pass through our system about once a year, but they're usually too small to detect until Pan-STARRS-1 came along. The discovery of 1I 2017 U1 was significant, not only because of its extraterrestrial origin, but also because it carried valuable information about the composition of distant celestial bodies. The Hawaiian observers fittingly nicknamed it Oumuamua, which means a messenger from afar arriving first in Hawaiian. After the initial observation, the messenger, referred to as Oumuamua, underwent detailed examination by various observatories, including the European Southern Observatory's ESO Very Large Telescope in Chile. The ESO's telescope measured the object's orbit and brightness and shared the images with a team headed by astronomer Karen Meach at the Institute for Astronomy in Hawaii. The team discovered that Oumuamua's brightness fluctuated by a factor of approximately 10 every 7 hours, indicating that the object was spinning or tumbling around its longer axis. This observation led Meach to conclude that Oumuamua had a highly elongated shape, estimated to be around 10 times longer than it was wide, with a complex and convoluted form. Now, before we take a deep dive into what's unusual about the shape, please be sure to subscribe to the Insane Curiosity channel if you haven't already. This helps support the channel and ensures you don't miss out on future high-quality content. What makes the shape of Oumuamua so remarkable? The shape of Oumuamua is one of the most intriguing aspects of this cosmic visitor. Usually, asteroids, meteors, and comets originating in our solar system tend to look like big, chunky boulders, with their width not too dissimilar to their length. However, Oumuamua appeared quite different. Oumuamua had a long cigar-like shape with a length estimated between 100 and 1,000 meters and a maximum width of only 35 meters. In other words, its length was more than 10 times its width, similar to fitting up to 10 football fields along its length and only 2 bowling lanes across its width. Observations by the European Southern Observatory (ESO) also provided clues about the color and composition of Oumuamua. It had a reddish color similar to objects in the outer solar system, suggesting it was a dense, dry object composed primarily of rock and metals. The reddish hue was likely the result of millions of years of exposure to cosmic rays on its surface. Based on its lateral motion observed from Hawaii, the scientific team hypothesized that Oumuamua had been wandering freely across the Milky Way for possibly hundreds of millions of years before encountering our solar system. Undeterred by our curiosity, Oumuamua continued on its trajectory, passing the orbits of Mars, Jupiter, and Saturn before eventually leaving our solar system and heading towards the constellation Pegasus. While the teams in Hawaii and NASA observers speculated that Oumuamua may have originated from the direction of the star Vega in the constellation Lyra, this fact is impossible to prove conclusively. The interstellar traveler's journey through the stars may have begun hundreds or even thousands of millions of years ago when the observable constellations were in different positions. What are the most widely held theories and hypotheses on Oumuamua, and what's the fact? Astronomers were puzzled when they first spotted Oumuamua, the first interstellar object detected passing through our solar system. They had a fairly good model of what the object looked like, a long, cigar-shaped body, and a vague idea of where it was headed, but they had absolutely no clue where it had originated from or exactly what it was. This led to a heated debate among astronomers, with some putting forth rather interesting hypotheses. Initially, the scientists split into 2 main camps: Team Comet versus Team Asteroid. To understand the debate, it's important to first clarify the basic differences between comets and asteroids. Asteroids are rocky objects smaller than planets that usually orbit the Sun. Comets, on the other hand, are made of ice and dust. When a comet approaches the Sun, the heat causes it to release gases and dust, a process known as outgassing. This outgassing leaves behind a coma or tail trailing the comet. The change in speed observed in Oumuamua was compatible with comet-like behavior, as comets have highly elliptical orbits and tend to accelerate drastically as they get closer to the Sun. This lent support to the comet hypothesis. However, there were 2 significant problems with classifying Oumuamua as a comet. First, the object was observed to accelerate even as it was moving away from the Sun, which is unusual for a comet. The outgassing process may have somehow acted as a propulsion system for this interstellar object. Second, Oumuamua did not appear to have a coma or tail, meaning it was not spewing out gas like a typical comet. So, while Oumuamua may have resembled a long cigar-shaped object, it certainly didn't leave behind a trail of smoke, dust, or gas like a comet would. This puzzling observation led the astronomers to consider other potential explanations for the mysterious interstellar visitor. In 2018, astrophysicist Roman Rafikov from the University of Cambridge proposed a groundbreaking theory about the mysterious Oumuamua project. Published in Quantum magazine, Rafikov's hypothesis suggests that Oumuamua is not a comet or asteroid, but rather a shard from a distant dying star. According to Rafikov, a dying star's immense gravitational pull can shred and rip apart asteroids, moons, and even planets, breaking them into smaller fragments. Oumuamua, he proposes, is one of these fragments sent hurtling through space from a dead star. This theory takes on a terrifying tone when considering the fate of our own solar system. Fun fact, scientists at the University of Warwick believe that this is what will happen to our solar system when the Sun eventually becomes a white dwarf and destroys us. That's a cosmic horror, right? A far-off dying world being destroyed by a dying star? But what if the last inhabitants of that world sent out one last message into space? Alternatively, what if it was a thriving civilization that dispatched a spacecraft to explore the cosmos? Rafikov's theory raises the intriguing possibility that Oumuamua is an artificial object, an extraterrestrial spacecraft visiting our star system. While this idea may seem far-fetched, accredited astronomers have taken it seriously, seeking evidence to support or disprove it. The possibility of alien life sending a message or vessel into the vast expanse of space is a tantalizing one, and Ravikov's theory has sparked a new wave of interest in the search for extraterrestrial life. In January 2018, a team led by Emilio Enriquez from the Department of Astronomy at the University of California, Berkeley, published a paper titled Breakthrough Listen Observations of One Eye Oumuamua with the GBT. The paper discussed the idea that advanced extraterrestrial civilizations could potentially send probes to other stars for exploration or communication purposes, likely equipped with radio communication technology. Enriquez and his team conducted an observation campaign directed at Oumuamua, the first known interstellar object to pass through our solar system, using the Robert C. Byrd Green Bank Telescope, GBT. The goal was to detect if the cigar-shaped object was the source of radio emissions consistent with a technological source, as Oumuamua presented a unique opportunity to search for extremely weak transmitters, unprecedented in any other SETI experiment. Over 2 weeks, the Berkeley researchers covered the full rotational phase of Oumuamua using the GBT's 4 different receivers, searching for narrowband 3 Hz resolution drifting sinusoids over a drift rate range of plus or minus 2 Hz. Such a narrowband emission, if proven, could have indicated the presence of a transmitter located on the object. However, the research team's preliminary results showed no narrowband radio emissions from the direction of Oumuamua at any rotational phase, suggesting that the object was not a crewed or automated vessel dispatched by an alien civilization. In September 2018, Harvard astronomer Abraham Loeb proposed a novel hypothesis about the mysterious interstellar object Oumuamua that had recently been detected passing through our solar system. Loeb suggested the possibility that Oumuamua could be a technological relic, a piece of advanced equipment from an extraterrestrial civilization now drifting as space junk after losing power over millions of years. Loeb noted that many stars are known to host Earth-like Goldilocks planets, some of which may have developed technology similar to our own. Like us, these civilizations may have sent a multitude of spacecraft and probes into the void of interstellar space, many of which could have degraded into relic-like objects over time. Oumuamua's unusual properties, such as its deviation from a purely gravitational orbit, led Loeb to speculate that it could be an artificial light sail or solar sail, a type of spacecraft that uses the pressure of starlight for propulsion. The authors suggested that as Oumuamua entered the solar system, it may have received a boost from the sun's radiation pressure, which could explain its observed acceleration. However, there is a caveat to this proposal. For radiation pressure to be the cause of Oumuamua's acceleration, it would have needed to be extremely thin, with a tiny mass-to-area ratio. Loeb and Bialy themselves estimated Oumuamua's thickness to be just 3 millimeters, with a radius of 20 meters. These dimensions are inconsistent with the data collected by the Very Large Telescope and other observatories. As the debate over Oumuamua's nature raged on, the mysterious object continued to speed farther and farther away, making it increasingly difficult to conduct additional observations. Ultimately, the exact nature of Oumuamua remained a mystery, at least until more evidence emerged in 2023. What evidence was found? What's the most profound explanation to Oumuamua? On March 22, 2023, the prestigious journal Nature published a comprehensive study conducted by Assistant Professor of Chemistry Jennifer B. Bergner from the University of California, Berkeley, and researcher Daryl Z. Slegman from the Department of Astronomy at Cornell University. The two authors sought to provide a plausible solution to the enigmatic acceleration experienced by Oumuamua, the first known interstellar object to venture into our solar system. According to the researchers, Oumuamua originated as an icy planetesimal. Planetesimals are small celestial bodies composed of rock and/or ice that form within the protoplanetary disks of protostellar systems. These diminutive objects continue to coalesce until a fully fledged planetary system emerges. In our own solar system, small asteroids represent the surviving remnants of planetesimals. Hence, Oumuamua was essentially a massive chunk of ice similar to a comet. In their model, Oumuamua began as an icy planetesimal that underwent irradiation at low temperatures by cosmic rays during its interstellar odyssey and experienced gradual warming during its traversal through the solar system. The researchers' detailed model demonstrated that Oumuamua traveled across the expansive Milky Way, absorbing high-energy cosmic rays emitted by supernova events. These powerful rays may have transformed roughly one-third of the planetesimal's water ice into hydrogen, which remained trapped within the ice. When Oumuamua entered our star system, the sun's radiant heat triggered the release of entrapped hydrogen. The discharge of this gaseous fuel acted as a propellant, favoring the observed acceleration of the interstellar wanderer. Moreover, the release of hydrogen did not leave behind a visible tail, as it possesses a lower mass compared to carbon monoxide and carbon dioxide, the gases typically expelled by comets. In the author's own words, we report that the acceleration of Oumuamua is attributed to the release of entrapped molecular hydrogen that formed through energetic processing of an H2O-rich ice body. Professor Bergner further commented, "We do not need to invoke any extraordinary explanations to account for this behavior." Suddenly, the puzzling speed boost did not appear to be a matter of chance after all, and there was no necessity to invoke technological relics, as captivating and intriguing as that hypothesis might have been. Before we continue, make sure to hit the subscribe button and click the notification bell to stay updated with our future videos. While Oumuamua gained public attention as an intriguing interstellar object, ISO, it is not the only one that has ventured into our solar system. In fact, just 2 years after its discovery, in August 2019, amateur astronomer Gennady Borisov and his self-built telescope found the second ever interstellar wanderer, 2I Borisov. Astronomers believe that advances in technology will enable us to detect up to 7 ISOs passing through our star system each year. However, the challenge with Oumuamuas and Borisovs of the cosmos is that they do not follow a fixed orbit around the Sun, but rather speed through our system before disappearing forever. This transient behavior makes it exceedingly difficult to study them in depth, especially from our Earth-based telescopes. While we could attempt to get closer to these interstellar visitors in the future by using spacecraft like the Comet Interceptor developed by the European Space Agency, a more specialized approach may be warranted. In February 2024, Alan Stern, the principal investigator for NASA's New Horizons mission, published a paper advocating for the creation of a purpose-built robotic craft, an Interstellar Object Explorer, IOE. Stern says a close flyby of an ISO stands as the next logical step in exploring the early history of both our own system and exoplanetary systems. The proposed IOE mission could finally give us a close-up look at the interstellar objects that zip through our solar system, unlocking secrets about planetary formation beyond our own. Now over to you. What do you think Oumuamua is? Is there any need to prepare for its return or the arrival of similar objects? Feel free to leave your answers in the comments below. If you liked the video, then you should check out the one on your screen. This dive into the most massive objects in the universe will blow your mind. Thanks for watching.